Hi, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Please join me on the journey to a clean, sustainable nuclear energy future by liking, subscribing, and commenting. Today we're going to be looking at a heavily requested video called Time-Lapse of the Future, A Journey to the End of Time by Melodysheep. I believe the subject matter of this is heat death of the universe. And that's all due to the second law of thermodynamics. The second law of thermodynamics says that entropy or heat disorder will always increase. Another way of looking at that is it is impossible to flow from a cold reservoir to a hot reservoir. It has to flow, energy has to flow from hot to cold. That is to say, you leave your cup of coffee sitting on your desk, it's going to make the rest of the room a little bit hotter, and it's going to get much colder over time. Now, why is that the heat death of the universe? Well, there's not a whole lot of heat sources in this infinitely expanding universe. As this universe continues to age and expand outward, and these heat sources use up all of their fuel, it's just going to get colder and colder and colder until there's nothing left. It becomes a very cold, dead place. Let's take a look at the video. Doubling every 5 seconds, okay? This video is about 30 minutes, so yeah, I don't feel like doing the math in my head. Yep. 29.
The Holocene has ended. What we do now and in the next few years will profoundly affect the next few thousand years.
Anthropocene means era of mankind.
The only conditions modern humans have ever known so far are changing, and changing fast.
Nothing stays the same on this planet. Everything changes. The Earth is going into one of these jumps, and you don't know what is going to be on the other side of those jumps. The Earth is always...
Magnetic fields flip every few thousand years.
Things move on this planet. Things are not still. Everything is...
On the asteroid impact, we're talking probability is such that we likely would have taken a hit with a 30-meter asteroid at some point. 30 meters, it's probably big enough to destroy a city. Tropical island. It's always fascinating to me how one of the last remnants of human civilization, I'm assuming, a million years from now we've all moved on to some other part of the galaxy or the universe, that, yeah, those footprints, because it's not a dynamic atmosphere on the moon, it does take a while to go away. Stone monuments erode. 3 million years? What do you think of that down in the comments? That seems like a long time for those things to stay around. If you're talking about like Stonehenge or the Sphinx or something like that. Gamma ray bursts. 10 million years, being within range of one of those super. Maybe. They have kind of a wide thing, so they kind of fun out as this big cone of death. So yeah, maybe 10 million years, sure. Ring Mars. No ring Saturn. Thinking major, we're talking like the one that killed the dinosaurs.
As it begins to run out of fuel, the sun won't simply fade away to nothing.
So it said increase luminosity. At 1 billion years from now, I think we're only talking like 20%. Doesn't take a whole lot much. It just gives a sense of what a delicate balance we have here between, you know, our Earth, Moon, Sun system here. And that's what it takes to wipe out all life. Well, all plant life, and presumably the rest of it will fall in about a few more seconds.
Its core will collapse, and the extra heat this generates will cause its outer layers to expand. The sun is now dead. It remains slowly cooling in the freezing temperatures of deep space.
I'll stay a white dwarf for a while.
The fate of the sun is the same as for all stars. One day, they must all eventually die, and the cosmos will be plunged into eternal night.
All stars eventually will run out of fuel. The temperature of the universe drops. The stars, one by one, in the night sky.
And this is such a small fraction in terms of the age of the universe that we're just talking trillions. And, you know, this end of time, it's going to go past like 10 to the 100th power years or something.
Eternal. And there'll be no more new stars created. And so that the universe will end not with a bang, but with a whimper.
That second law of thermodynamics
Not
doing
in
its
fun.
job.
But nice.
Red dwarfs last the longest, not counting white dwarfs.
With no fuel left to burn, a white dwarf's faint glow comes from the last
White dwarfs last a while, hence they're having all this time talking about it at this scale of doubling speed every 5 seconds.
residual heat from its extinguished furnace. Looking at it from where the Earth is now, it would only generate the same amount of light as the full moon on a clear night. The faint glow of white dwarfs will provide the only illumination in a dark and empty void littered with dead stars and black holes.
Humanity's descendants could theoretically live around one of these, though. It's a source of heat. Just got to live a little bit closer to it, and by a little, I mean a lot closer to it than we do to the sun.
in some ways, it's kind of a ghost universe. It's the corpses, the zombie stars, that will take us into the future.
That's cool. So yeah, when you're dealing with timescales such as this, even things that are like super low probability of happening, like stars, planets running into each other, these things happen. It's funny to think about that things with low odds will eventually happen. But so yeah, we'll get a few more stars out of brown dwarfs making new ones. Yes, think of it as like an ember from the extinguished campfire of the universe landing on something and having it catch fire for a little bit. These are cool. Neutron stars, ultra dense superstars, making this kilonova is another word for these neutron star collisions. And this is one of the explanations of where super heavy elements like uranium have come from. Just really, really cool. That, yeah, smashing these ultra dense things together, and now we use it for fuel in our nuclear power plants. It's just fascinating to me. That's cool, making ring worlds around white dwarfs.
A black dwarf will be the final fate of those last stars. White dwarfs that have become so cold that they barely emit any more heat or light. Black dwarfs are dark, dense, decaying balls of degenerate matter. Little more than the ashes of stars. Their constituent atoms are so severely crushed that black dwarfs are 1,000,000 times denser than our sun.
Ooh, white dwarf.
Stars take so long to reach this point. We believe there are currently no black dwarfs in the universe.
I can believe that, because our universe is only, was it 14.7 billion years old, or is it 13.7? And now we're at 1,000 trillion years? As that little toolbar says. I prefer scientific notation. Let me know if you like their notation of it in increments of trillion years. At this point, you wouldn't see this color or anything around black holes, but I know they're doing it just to make the video look cool, which I fully support. But again, you really wouldn't see these black holes at all. Yeah, it looks so cool. That would be so cool. Rotational energy from as a power source. You get a lot.
We have a pace of life that's based on really the energy available to us now. you could imagine living conscious systems which have a very different pace and therefore can extend out at least a lot farther than you'd imagine otherwise. You could have a living system where if it had a thought every 10 trillion years, that would seem normal.
Yeah. After all, I've known some people that take trillions of years to decide what they want to have for breakfast.
Even if our life dies out, one could imagine at some time arbitrarily far in the future, a fluctuation occurs which allows intelligent life to exist again for a little while. So you might have islands in time of intelligence.
That's a cool concept, though. What would a being like this even look like, though? It's completely invisible, live in space, presumably using rotational energies of black holes as a power source. It's fascinating. So this point right here brings up this. I know they're leading into heat death, but expanding faster than the speed of light and continuing to accelerate. Doesn't that break things? As in, we're talking like ripping stuff apart, like the universe starts expanding, that everything will eventually just tear itself apart, even going down to atomic nuclei. I know the Big Rip is a thing, but maybe we're just gonna pivot on that and go the whole Big Freeze direction with the whole heat death. Let me know about that in the comments. What are your thoughts on the whole Big Rip? Would have it, at the rate of expansion increase, would it have occurred by billion, trillion years? So this is different from like radioactive decay, but even the so-called atoms that aren't really radioactive, they really are. It's just a very, very long time scale that we can assume they're stable at this point. Now they're getting into proton decay. Its half-life, if it exists, we're talking, yeah, the trillion years, or what does that figure out to? Getting close to 10 to the 40th power of years. Yeah, it just might just last a really long time, and it's difficult to measure because the universe is so young at this point.
Fundamental building blocks of atomic matter, what makes us up, can just spontaneously fall apart.
Any material that evades the pull of a black hole eventually dies away.
I wouldn't even know what it would decay into. Would it just be pure energy, pure like gamma radiation or something?
As its protons disintegrate.
Using the term disintegrate, so presumably something that's massless. Compared to, say, a neutron decays into a proton and an electron, but neutrons are bigger. Protons are more fundamental.
The matter inside black dwarfs, the last matter in the universe, will eventually evaporate away and be carried off into the void as radiation, leaving absolutely nothing behind.
Second law of thermodynamics doing its job.
With the black dwarfs gone, there won't be a single atom of matter left. All that will remain of our once rich cosmos will be particles of light and black holes.
Things that have no mass and things that have a lot of mass. So we're not even at the halfway point, and we're already down just black holes and light. That's something. Why do we exist at this point in the universe?
The arrow of time creates a bright window in the universe's adolescence, during which life is possible. But it's a window that doesn't stay open for long. As a fraction of the lifespan of the universe, as measured from its beginning to the evaporation of the last black hole, life, as we know it, is only possible for 1,000th of a billion billionth billionth.
This guy likes billion. The toolbar below likes trillion.
Black holes become the fundamental building block of the universe.
That's true. With no atoms, what else do you have?
A galaxy will basically be a supermassive black hole in a center with smaller black holes orbiting it.
Zombie galaxies filled with black holes continue to evolve.
They'll eat each other and they'll get bigger, and maybe they'll fall into the supermassive black hole and it'll get bigger. The universe will still be an exciting, dynamic place. It's just that the timescales you're talking about are now trillions of years instead of thousands or millions of years.
That looks cool. Again, there'd be no light, but it's cool. I think the biggest supermassive black holes there are now, we're only talking the order of millions to billions. Not any trillions yet, but during the black hole era, sure.
Black holes can bang on space-time like mallets on a drum.
That's cool.
And have a very characteristic song.
Black hole ballet.
Imagine two black holes that have lived a long life together. At the end of their lives, they're going around
cute.
each other, crossing thousands of kilometers in a fraction of a second. As they do so, they leave behind in their wake a ringing of space, an actual wave on space-time. Space squeezes and stretches as it emanates out from these black holes banging on the universe.
It's quite romantic, actually.
Those are the
black hole
gravitational
dancing.
waves, literally the sounds of space ringing. And they will travel out from these black holes at the speed of light as they ring down and coalesce to one spinning giant black hole. If you
Someone in the comments let me know if they is like the shipping or a romance story about black holes. I kind of think that's a thing after watching this scene.
standing near enough, your ear would resonate with the squeezing and stretching of space. You would literally hear the sound. Imagine a lighter black hole falling into a very heavy black hole. The sound you're hearing is a light black hole banging on space each time it gets close.
I like they're having all this extended stuff on black holes because that's how
As it
long
falls
the
in,
black
it gets
hole era
faster,
is.
and it gets louder.
We're maintaining that same exponential pace. Oh, that is cool.
Scientists used to think black holes were mortal, but even these will one day die.
Now we're talking about time scales of unimaginable length, quadrillions of years into the future. On that time scale, even the black holes begin to evaporate.
Now we're up to trillion years.
According to quantum mechanics, space is filled with virtual particles and antiparticles that are constantly materializing in pairs, separating, coming together again, and annihilating each other. In the presence of a black hole, one member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle appears to be radiation emitted by the black hole.
So this radiation, as Microsoft Sam is explaining, this Hawking radiation, all these virtual particles, super slow way of black holes to decay and evaporate. Starts off on this super slow time scale. Now it will rise exponentially, but it's a slow build exponentially as the black hole continuously gets smaller and smaller, but we're talking a lot down below in terms of years that, yeah, these things will evaporate. And the reason why, at least according to this virtual ghost particle theory, is first law of thermodynamics. Energy cannot be created or destroyed. So that energy's got to come from somewhere in the point of radiation from the black hole.
And so, black holes are not eternal. They evaporate away at an increasing rate until they vanish in a gigantic explosion.
First bit of light you've seen.
Quantum mechanics has allowed particles and radiation to escape from the ultimate prison, a black hole.
Fireworks. The whole dark energy thing.
Philosophers and poets have asked the question, will the world end in fire or ice? We can now give an answer. The latest evidence shows that the universe is not slowing down, but it's speeding up out of control. And the universe, we think, will die in ice. Trillions upon trillions of years from now.
Empty space itself
has energy. In every little cubic centimeter of space, whether or not there's stuff, whether or not there's particles, matter, radiation, or whatever, there is still energy, even in the space itself.
There is, according to the first law, the amount of energy in the universe has actually remained the same the entire time. It's just sitting in space. Things have just gotten a lot less complicated. Nothing's really dead. Nothing really went away. It's just everything got a lot less complicated, and that's what the second law does to you, or does to the universe.
And this energy, according to Einstein, exerts a push on the universe.
What is the weird stuff that's accelerating the universe? We call it dark energy. And this stuff is the dominant stuff of the universe. Almost 3/4 of the matter-energy content of the universe is this dark energy. And we don't know what it is.
Yeah.
Dark energy, unlike matter or radiation, does not dilute away as the universe expands. This has crucial implications for what the universe is going to do in the future.
So what will be the future of the universe? Well, if the dark energy remains dominant and repulsive, the universe will expand forever. Faster and faster and faster with time. A runaway universe.
70% of the energy of the universe resides in empty space, and we don't understand why.
Still, if it gets faster than light, I still don't see how it's not tearing the universe apart, but again, we just don't understand it.
But we do know what will happen. If that energy continues to be there, the universe will become cold and dark and empty. That's the future as it might be. We don't know because we don't yet understand the nature of dark energy until...
By the way, they're just talking about dark energy more, but it's been there the entire length of the video, and it's been expanding at an increasing rate this entire time. They just didn't really bring it up until now. Just keep that in mind.
We won't know the future. We won't even understand our own origins, and that's why we want to know and study this subject.
Oh yeah, I believe that. Okay, here we go. Big crunch, big rip. Big crunch, it would lose to gravity, and gravity would pull it back together. Big rip would be the continuous acceleration that I was talking about at pulling the universe apart. And then heat death would be it continues to expand, but it never hits a point where it tears the universe apart. Are we still in the black hole era at this point? I thought those all went out. Should be in the dark era at least soon.
Forecast does seem to be for an ever colder, ever emptier universe. But then, of course, we have to ask, could that end lead to a new beginning? And there are ideas whereby what actually is the end of our universe could in some sense be linked to the beginning of a new one.
Way to escape before entry.
We've worked out the mathematics.
If you escape, though, but then part of it depends on the whole proton decay. If you're like taking particles from your universe, I guess you'd have to make them from scratch over again. Yeah. You don't want to spread the same. If protons don't exist, they'll still eventually run out, but I guess if you create a new universe, you kind of start that clock over again. This is crazy, and I love it.
The equations, they seem to say that if you have an atom smasher that can concentrate tremendous amounts of energy at a single point, you can perhaps open up a gateway, a baby universe. Facing the death of everything there is, this perhaps is their only possibility of escape. And this also raises a very intriguing possibility, sheer speculation of course, that perhaps any universe that has intelligent life in it will create baby universes, will create lifeboats, and proliferate child universes.
Maybe we're created by an advanced, intelligent civilization, and we're one of these little pod universes sitting out there. Something.
So an evolution may take among universes in the multiverse. Survival of the fittest may take place. So those universes which do not have intelligent life are infertile. They have no children. Those universes that have mild temperatures, stars like us, would create civilizations that could open up child universes, and they would then proliferate.
That's a fascinating way to... Wow, that's just cool. Here, our last black hole evaporates. I like that. The current universe basically got so boring in this video, we started talking about other universes, and just now the last black hole evaporated. There it goes. What, up to eight times the word trillion's been written down
After
there?
an unimaginable length of time, even the black holes will evaporate, and the universe will be nothing but a sea of photons gradually tending towards the same temperature as the expansion of the universe cools them towards absolute zero. Once the very last remnants of the very last stars finally decayed away to nothing, and everything reaches the same temperature, the story of the universe finally comes to an end. For the first time in its life, the universe will be permanent and unchanging. Entropy finally stops increasing because the cosmos cannot get any more disordered. Nothing happens, and
At that point, you're at absolute zero. That's the third law of thermodynamics.
keeps not happening forever.
Wow. That was really cool. Quite the journey through time, if you will. I like the idea of us being able to make artificial universes, and we're probably in an artificial universe of maybe another sufficiently advanced civilization. What do you guys think about that down in the comments below? Are we in an artificial one? Or are we like one of the first ones ever? Maybe. Thank you very much for watching. I'll see you next time.